let's talk about making data tables. So this is a data table. I'll kind of show you how it's structured, but you basically set up the structure itself here and here, and then all of this in the middle is self-populating parts that are green and red. So I'm going to delete some of this and redo it. But the idea is if I want to test here if variable costs change in our projects, right now variable costs are feeding up into here, and I want to see if this number changes, what happens to the model at the same time that if fixed cost changes, what might happen to the model. So I'm going to copy my variable cost that is calculated, and I'm going to therefore right click and paste special values. So I'm just going to put this in. You'll see it's now just a number. You do not want to hit equals and click this cell. That's not a good idea. These data tables are manipulating this particular cell. You're having it change things in this cell, and so it can't be tied to that cell. That makes it not work the way you want. The other thing we can manipulate here are fixed costs. I'm just going to take year one fixed cost here and make it $128,000. And then I'm going to say if that goes up or down, if this goes up or down, what happens to the NPV? So the data table, you hit equals. This is the only place you hit equals. You tie it into where in the model, which in this case I want to know what happens to the net present value. And then it will feed whatever's here. It'll feed whatever comes out here when you change those variables into this array down here, this matrix. And so I'm going to say, what if this goes up by 10%? So multiply by 1.1. What if this goes up by 20% from our assumptions? Oh, what did I do? Equals that times 1.2. Okay, so if it goes up, or if we're wrong the other direction, 10% down times 0.9 times 0.8. So there's our different variable costs. We'll do the same thing here with fixed costs. This times 1.2 equals this times 1.1 equals this times 0.9 equals this times 0.8. So up or down 10 or 20%. And then the data table itself, and again, you can set this up without all the borders and stuff. So if you hit equals NPV like that, and then you type these numbers in going over here and those going down, I just have the borders all set up since I already had it built. So you can do it in a blank space. It doesn't really matter. You can do more than 5. You can do a table that's like 10 by 10 if you wanted to, or even 2 by 2. It doesn't have to be of any particular size. But you just then highlight the table itself. So this is where you want the table to be. You want all of these things included, and that also highlights the array you want to be filled in by the differing values of NPV, and I'll come back to what those are in just a second to make sure you understand. And you go to data, you go to what if analysis, you go to data table, and it says row input cell. Rows go like this, columns are up and down, just like Roman columns like we've talked about in class. And so the row input cell, we would like this row of inputs to be fed into this place right here, and we'd like the columns inputs, these column inputs to be fed into here. And then we hit OK. And it's going to give us an array like this. So you should see where the current fixed cost is, 128,000, and the current variable cost of 68.68% should match NPV here if you've done it right. And then as variable costs increase, our NPV should go down because we're making less money, and as our variable costs go down, our NPV should go up. That's true. Same thing, fixed costs. As fixed costs go up, that's bad. So the NPV goes down. As fixed costs go down, it should go up. So it looks like everything's working correctly. By the way, I already have conditional formatting on here. I'll show you how I did that as well. Home, conditional formatting, clear rules. So we'll just clear all the rules. So then what I like to do is after I've built the table like that, I like to go to this, home tab, go to conditional formatting, highlight cells greater than 0. I make green. Okay, and then I do a second rule, highlight cells rule less than 0. I like to make red, and that makes it very clear where this project is a good idea at a positive NPV, but as we get fixed costs increases here and variable cost increases, if fixed costs go up by 10% and variable costs go up by 10%, then we're in the negative. All right, if fixed costs stay flat and variable costs go up by 20%, we're in the negative, etc. It kind of lines that out. You can also see from here to here, it's less than 300,000. So variable costs aren't, or fixed costs aren't very volatile. This is keeping variable costs constant, and if I keep fixed cost constant, variable costs going up or down by 20%, there's over a $4 million range in NPV. So that's kind of a bigger deal. So we can see that there's more risk in the variable costs and things like that. But you can see then if I plug any of these numbers in, so if I change this to 148, to 148,800, and I change variable costs to this number right here. So if I copy this and put it in here, it's going to change to this 44,548 is what it should do. So paste special values, because again it's calculated. Now our NPV is negative 44,548, so it matches up here. So that's all it's doing, is it's literally taking this and putting it in here, and then it's taking this and putting it in here, and then it's taking this and putting it in here, and taking this and putting it in here, and it's just reporting all the NPVs for all the different permutations of variable costs and fixed costs that I've set up here. Okay, that's how you build a data table. It's useful in a lot of places. This just happens to be the one I use it most often, and it is in capital budgeting. Anyway, that's it for today.